Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills they need to get their first software development job, building Windows and web apps at the world's best companies as quickly as possible. So in this lesson, we're going to talk about collections, which are kind of like more full-featured arrays, full-powered arrays. I'll also talk about object and collection initializers, which allow you to initialize all of the properties for new instances of objects or collections of objects in just one line of code. Very cool. So previously we looked at arrays and we said that an array is simply a sequence of data of individual elements of data that are stored in memory. And you can access any individual element in that sequence by using its index, which is its zero-based ordinal position inside of that array. We called it a bucket of buckets, and we can access any of the smaller buckets in the array by just saying I want number 3, which would be the fourth bucket in the array, right? So arrays are great, but we noted that they lacked a number of features. Like right out of the box, the length of arrays are fixed once you declare them. We saw that there was a helper method that would allow you to resize the array. But what if I didn't want to use an index, let's say, for example? Instead, I wanted to use some sort of key. And so by using, for example, a ISBN number, I could find the book that's associated, the book object associated with that number. I may not want to always do a lookup merely by the ordinal position in the collection, but rather use some other criteria. So, for example, what if I were working with customer data, I wanted to look up a specific customer by their last name or some other key that I've defined? Well, you can do that using collections with different types of collections. So to demonstrate some of the features and the limitations of collections, I created a setup project. It should be available from wherever you're currently streaming this video or wherever you originally downloaded this video from. You should be able to unzip it. Now, I've unzipped that file into my documents directory. If you take a look, for example, in lesson number 22 folder, where you should have unzipped this the code for this lesson, there should be a before and after folder. In the before folder, there should be a project called Working with Collections. I'm going to merely copy that and put it into my Visual Studio 2013 projects directory. So I'll just right click here in the open space and click paste. And then to open this up, I'll drill into the solution folder and double click the SLN file, workingwithcollections.sln. That opens up Visual Studio with my project. And so let's take a quick tour of the project itself. You can see that there are several files here in the Solution Explorer. There is a car class and a book class, and then also the module 1.vb. The book class just merely has a couple of string properties, title, author, and ISBN. The car has just a make and a model, very simple in this case. And then in the module, I create instances of the car and the book, and I will be adding them to various types of collections to illustrate the differences between them. So here I'm creating an instance of car, an instance of car, an instance of book. All right? And so I want to start by demonstrating how the original .NET collections worked and why we now have a newer style of collections based on the concept of generics that I'll explain in just a moment. So you can see that, well, first of all, what I want to say is that there are many different types of collections available to you in the .NET Framework class library. So I'm going to start with a type of collection called an array list. So each collection features a unique set of functionality. Since I want us to just get our feet wet, I've chosen something fairly simple. We'll start with the array list, which behaves a lot like the array, except for a few extra features that are added to it. Now, I don't want you to use these old style collections, so there's no real value in typing out what I'm about to type. I just wanted to show you this progression of thought. As I mentioned before, there's a new style of collections that we're going to use. I want to start with these original ones that were created in 2002 with the original .NET Framework class library and kind of walk you through the thought process of why they were problematic and what the new collections since 2005 give us and support that we were lacking originally. So don't feel like you have to type all this in. Just follow along for now. All right, so first of all, I'm going to work with the array list type, and I'm going to call this my array list as new system.collections.arraylist. All right. and then we will merely add items to our array list. So we called our car instances car1 and car2, and then the book b1. So let's add each of these to our array list. So car1, and then my array list add car2, and then my array list dot add b1 for the first book. And now what I want to do is just do a for each my car as car in my array list, and we'll just simply console.writeLine my car.make. All right. Now hopefully you see a little problem here that's brewing. I've added 2 cars, but I've also added a book. When we add objects into these old style collections, they're added in as type system.object. And you recall from previous discussions that system.object is kind of the class from which all other types, all other classes in the .NET Framework class library, and all other types that we create derive from. And so they get cast to object, and now we're casting them again back to cars here in our for each in order to retrieve some value from that object. But not all of the things that we've added to our array list are of type car. Here's something of type book. So when we run the application, we get an exception. This is an explosion of windows pop up. It says invalid cast exception, unable to cast object of type working with collections.book to type working with collections.car. Fundamentally, we're still working with a book here, and so when we try to cast it to a car, we get that exception pop up. So herein lies our first challenge, that our array list accepts type object, which seems great at first, but we're essentially working with loosely typed objects, not strongly typed objects, and therefore, because we can accept anything, getting it back out of system.object and into its original form is problematic. As you can see, we'll hit an exception. So there are some neat things about the old style collections. They did introduce us to the ability to do something like this. We can actually remove items from the list, and it should work correctly. In this case, I've added a book, and now I'm going to remove the book. And hopefully, by doing that, our application will run correctly. All right, and it does. Great. A collection size is not immutable like an array is. And there are some other great features too. If we were to just go my array list dot and take a look, we can add a range of items, we can search, we can clear out all the items, we can get a count, we can insert at a specific position, we can reference a single item in the array, we can remove at a specific position, sort the items in the collection, and even convert back to an array if we like. So there are some very neat features of the array list. However, it's problematic, as we noted, because it's not strongly typed. So let's go ahead and comment this out and move on to the next example. And this time what I'm going to use is a list dictionary. And so let me just start by typing, and then I'll explain what the difference is if you don't see it right off the bat. Okay, so hopefully you can see that the process of adding an item to the dictionary is different than adding something to the array list. We were able to pass in a key and the value itself that we want to store. So List dictionary is named after a family of collections called dictionaries because they have a key that we can use to reference a given item in the collection, and then the item itself, in this case, an object called car, an object called car, and an object called book. Okay, so what we can do then to find a given item is to just use its key. In this case, the make would be geo. We'd be able to find and convert that object of type system.object back to a car and then retrieve the model property and print it out. However, the same thing that plagued the array list is going to plague us here, where we're able to add more than one type to this list dictionary, and as a result, when we try to cast a given object to type car that's fundamentally a book, we're going to hit an exception, and we do. It's the same sort of exception that we saw before, that fundamentally we can't convert that type. So I said all of that to say this. What if we were to create a type of collection that was specific to either book or car? Then we could only add instances of the correct type into that collection, and we could also treat all items in the collection as that given type, and we wouldn't have to cast objects upon retrieving them, and we wouldn't have to worry about if we were casting something that was incorrectly placed into the collection in the first place and hitting a runtime exception. So that's exactly what happened several years ago in Visual Basic 2005. Microsoft added a new set of generic collections. The concept of generics is a little bit advanced. In a nutshell, a generic type provides a basic implementation of some functionality, in our case, collections. However, you, the user of the generic collection, you make it specific by adding your own data type to it. So, for example, let me comment all of this. And let's create a new version of that first example. Now notice here, I'm going to give it of car. So we're creating a list of cars equal to new list of car. Now only cars can be added to my list. So we can do mylist.add car1, mylist.add car2. All's fine. Now let's try mylist.add b1, and whoops, we can see we get a blue squiggly line. The value of typed book cannot be converted to car. All right, so we're not even able to do that. So now whenever we do the next part for each my car as car, we can be confident that everything in this collection is a car. And so we can, with confidence, run our application. And we don't have to worry about there being a runtime exception. All right, so that's the benefit of using generics. It allows us to create strongly typed collections. All right, the same thing would be true of dictionary. So let's create that example as well. Now notice its definition. In IntelliSense, we're creating a generic version of dictionary, and we have to give it two types. So the of keyword is followed by two types, t-key and t-value. T-key will be the type of the key, our lookup type. So we're going to make that of string, and the value will be of type car. So if we just read the IntelliSense and think what it's trying to do, we can generally figure out what to put after the of keyword. Okay, that's would be my encouragement to you. Now when we try to create or add our car, whoops, we'll add, and we look at the IntelliSense below, we want to add a key, a string. So we'll go car1.make, and then car1, and then my dictionary add car2.make car2. Now let's try to add, and I think you know where I'm going with this, and you probably already anticipate this not working. Author and So at this point, we don't get a blue squiggly line because the author is a string. As long as we satisfy that data type, then we're fine. But what happens when we try to give it the actual object? Well, now let's try to give it B1, the object itself, and you notice that's where the problem comes in. You can see value of type book cannot be converted to type car. So that is a benefit to us. Now we don't have to worry about another data type slipping into our collection. So in this case, we'll just do what we did before with console.writeLine, and then we don't even have to do the conversion of the type because it can only be one type. So we can do my dictionary geo, and you can see we don't have to use that C type, that type conversion helper method in Visual Basic. Instead, we can just go directly to our model and run our application, and it should work fine. Great. Let's comment all that out. All right, so the next thing I want to do is move on to the final topic in this lesson. You might recall the initialization syntax for arrays. So we did something like this: dim names as string equals, we used the curly braces, and then I gave it the members of a popular band, like so. And now, all in one line of code, we've declared and initialized our new array. And this saved a few lines of code, first of all, and then secondly, we didn't have to tell it how many items were actually going to be inside the array itself. So let's use a similar style to create a new car. So dim my car as new car with, and then I'm using the curly braces again, and I'm going to use the dot, and I can set make equal to geo, and then comma dot model equals prism, like so. All right, and so here in one line of code, we're able to create a new instance, and then using the with keyword and the curly braces, we're able to set the individual properties of our new instance of my car to their initialized values. So that is an object initializer when you see this syntax, and it's used often out on the internet. So the syntax is easy. You just have to remember to use the with keyword and then the open and close curly braces with each of the property, name, and value pairs separated by commas. All right. So we can go one step further than that with collection initializers. So let's do this. So dim my list of cars as new list of car from, instead of using the with keyword, I use the from with collections. And now inside of the curly braces, I'm going to say, I'm going to create a new car with, and I'm going to use curly braces again, just like we did before. So we'll set the make equal to Aston Martin, and the model equal to a DB9. We'll use a comma to separate each new instance of car Notice that I forgot the period there. All right, let's continue on. And then we'll end it up like so. So the syntax might look a little daunting at first, but you'll see it so often in code examples that I wanted you to be aware of it. I recommend that you simplify it and you understand that you can use the same object initializer syntax by initializing new objects with the initializer syntax within a context of collections like we've done here. All right, so While this looks like about 4 lines of code, it's actually just 1 line of code. Once you wrap your head around the object initializers, like we saw here, then collection initializers are really easy. I just formatted this code by breaking it up into several lines, but again, it's technically just 1 statement. So after the declaration of our new list of car, then there's an opening and closing curly brace using the from keyword, opening and closing curly brace, and then creating new instances of car using the with keyword to set between curly braces as well, properties and their values. All right. Now notice that we don't give each of these instances of car a name that we can reference. There's no need for that. As long as we can create the reference, remember that this will now hold on to that reference, and as long as there's at least something holding on to the reference, it will retain in memory. But once we set my list of cars equal to nothing, there will not be any references to these objects in memory anymore because we don't have anything else holding references to them, and so they'll be removed by the garbage collector. All right. So that those same rules still apply, but as long as something's holding onto a reference, even if we don't have a name like car 3, car 4, car 5, like we created here at the very beginning with these, it'll still work as long as something is holding onto a reference of each of those new objects. All right? So you should familiarize yourself with the syntax, and you should use it right from the beginning so it becomes part of your personal style. So let's go ahead and recap what we talked about in this lesson. We started off by looking at collections as a robust alternative to arrays. But as we started using the basic collections that were available in system.collections, we saw that they weren't strongly typed enough, and therefore we discovered some downsides, some challenges. We were able to overcome them by using generic versions of those collections. A generic implementation of a collection that's made specific by supplying the data type that we wanted to work with for each of the parts of whether it be a dictionary or of a list, okay? So that's what a generic collection or method does. It allows you to define the specifics, and then it only accepts those types from that point on. So now we can work with collections in a strongly typed manner, and we saw how great of an improvement that was. There's no casting, no concerns about there being some type mismatch. It just works from that point on. And then finally we talked about the object initializer syntax, and we extended it to collection initializer syntax as a shorthand technique of creating instances of objects within a new instance of a generic collection. Looks a little complex, but really when you break it down into its component parts, it's actually really simple. Don't make it harder than it really is. Okay. So we're doing great. We're getting close to the end. Hang in there. We'll see you in the next lesson. Thank you.